Little three-line program, quite simple. So 10, line 10. Print, and let's have it at some random position across RND brackets 30. That will give me a random horizontal position up to column 30. And let's choose some random position down the screen, somewhere in the first 20 lines. And at that position, we'll print CHR $230, the little man. That's the first thing. Let's change his colour as well. We could colour random 3. That means some random colour. It's actually going to produce it either in red or yellow or white. And that will only print one man at some random position. If we want to go around again and print lots of men, we have to put at line 30, that horrible phrase, go to, but go back to line 10, and that'll send the program round and round again.
I've got a feeling you really enjoy programming this machine.
No, I really hate it, honestly, man. Clear screen, and run that program.
And there it is.
Right, lots of men, different colours, different positions on the screen.
Well, it's not quite animation. Can we actually make him move around?
Yes, you can. To do that, you have to have a set of characters with a man in different positions, and we've actually got them programmed in already. You can see 3 characters here. Position 230, he's standing. 231, he's standing up with his legs together. And 232, halfway flying through the air. So if we actually print those one after the other, we can make him appear to move.
Oh, yes. Well, is the code very complex for that?
No, it's quite a simple little program. I'll list it out for you. That's the total program to do that. I'll just explain it. The top section of the program here is a repeat until loop, and it goes round and round that many times, doing the following. First of all, print at that position on the screen the first little character, proc delay. Now that means have a small delay as a procedure to develop a very small delay so that we can actually see him before we then print in the same position the man in a second moving position. This
Otherwise
time
it would move too quickly if we didn't put the delay in.
That's right, you wouldn't be able to see anything, just a blur on the screen. Another small delay, and this time number 232, which is him right high in the air. Proc delay, another delay. And down below here we've got the procedure defined. Define the procedure called delay. We've got a clock inside this thing, rather like a stopwatch, and this first of all sets the stopwatch to 0 and then gets it running, and it says repeat nothing at all until time is greater than 20 hundredths of a second, or until 0.2 of a second has elapsed. So it whizzes round here for 0.2 of a second, and then end proc, it comes back to that point with the clock set at 0.2 seconds.
What's the meaning of this until time is greater than 10,000?
Well, that until is part of this repeat until loop. It goes round here, waiting for the time to get up to 100 seconds. Of course, it'll never actually get there because the clock, the stopwatch, keeps getting reset by proc delay, and it actually never gets above 0.2 seconds. So really, it just keeps going round and round this, and that really means repeat forever.
Oh, let's have a look at him again.
All right. That's the little man.
Well, it's pretty small. I guess if you wanted to use something bigger, you'd have to move several characters together at the same time. Is that possible?
Yes, it is. I've got a program here which will do that. This program actually illustrates 2 types of graphics. It's got both high-resolution graphics, which we've got on the screen at the moment, and it's drawing some grass and some flowers. And then it uses character graphics, in fact 4 characters joined up together, to produce a bee whizzing around. Now you can see 2 bees on the screen, third one appears. Let's stop the program there, and we can have a look at one particular bee, and that particular bee is actually made up of 4 separate characters, but joined together. And those 4 characters I've got mapped out on these cards. Let's show you how the bee is built up. There's the top left of the bee, the top right, the other bit and the last bit of the bee. And that group of 4 characters is what was used to draw the bee. Now those 4 characters are moved around the screen together. You know, it whizzes around the screen, buzzing as it goes. And in fact, you just use the print tab statement to print those group of 4 characters on the screen at any position you want.
Well, the bees are quite good fun, but they're not really high-resolution graphics, are
No, they aren't. They're drawn in character graphics. But even with character graphics, you can actually do some quite respectable things. You can draw some quite respectable and useful programs. Okay, so this is using the low-resolution character graphics, but even so, you can see that we can get some quite reasonable effects.
It still seems to be a lot better than your art is.
True.
Well, let's take a look at what we mean by high and low resolution. Look at this photograph. It's been broken down into 80 squares, which are either white or black. So it's got 80 bits of information in it. See if you can guess what it is. Each time we're doubling the number of bits, doubling the amount of information in it. That's about the level you get on Prestel or CFAX. Now we begin to really recognize it, and we're putting more information in now by producing greys. It won't get any sharper, but it will produce grey colors. And finally, we shall get a full color picture, and it takes about 5 million bits of information to display that color picture, and it isn't even moving. Well, that's the 80-bit picture, and we've doubled them up there to 160, which is about 20, it's exactly 20 bytes, and you can't obviously recognize it. Here we've jumped to 80 bytes, it's still not recognizable. And here we're into about 1,000 bytes, where we can begin to represent it on these small micros.
That's right. What we've tried to do is to draw a circle on each of these micros, and this group here is just using character graphics, so it doesn't show up very clearly. The best we can do is to display a single character to build up this circular image.
That's about the level you'd expect on Prestel or CFAX and so on.
That's right.
So you can begin to recognize what it is.
But the definition isn't very good.
No. This is what I call medium resolution graphics, yes.
That's right, but one has to be a bit careful. On some of these computers, really, they're described as high-resolution graphics, but if you're used to using a really big machine, then you might only regard this as medium resolution. That's a better phrase.
But they're high resolution compared with the actual character graphics.
Very much so, and suddenly you can see a very clear image. There's a tremendous difference between this and character graphics. These here are using about 10k bytes for the display. So there's quite a lot of memory needed, even at that stage.
Well, the next step up isn't quite as significant as it was between the character graphics and so on, but you can see a difference here. We're using about 20 or 30,000 bytes of information, and it really is quite sharp, isn't it?
That's right. But of course, we're still only looking here at black and white graphics. We haven't yet introduced any colour into the image. Now, if you want to introduce colour, then you need to store a great deal more information. We've got here a model of the screen built up of a whole load of dots. Now, if we have a look at a single point here, instead of just needing one bit of memory for each pixel, you may need several bits, some to describe the colour of the image and some to describe its intensity. So for a full colour image, a lot more memory is needed.
So that's the payoff, if you like. If you have high-resolution graphics, you need a lot of memory. The character graphics, you need a small amount of memory.
That's right, that's right.